So we'll review our objectives really quickly. We're going to identify and describe the benefits, costs, and longevity of living shoreline projects for potential clients. Respond to client questions and concerns about different types of shoreline stabilization options, including living shorelines. Understand the living shoreline permitting process for North Carolina. You heard that from Tara McPherson last week, but if you do have any permitting questions today, she's on the line and she can answer those. Conduct analyses of site factors to design living shoreline projects. We heard about that last week, so you can refer back to the video if you want to watch that again. How to implement non-structural and hybrid living shoreline projects. We'll get more in depth to that today with Lexia and Tracy's presentations. Understand how to secure materials and determine equipment needs for living shoreline projects. Again, we'll talk more about that today. And create business opportunities to monitor and maintain living shoreline projects post-construction. Ted Wilgus is going to get into that today. And finally, provide instruction to property owners on basic maintenance and how to evaluate project success. So our agenda today, we'll kick it off first with Lexia Weaver, who will talk about materials, supplies, and plantings. We'll take a 10-minute break around 10:30 a.m. Then we'll talk about constructing living shorelines and get more in depth with construction methods and some case studies from Tracy Scrable. Then we'll hear from Ted Wilgus about living shoreline monitoring, maintenance, and business opportunities. And we'll wrap it up again, talking about the field session and giving you the link and time to complete the training evaluation. So with that, I am going to turn it over to Lexia.
All right, good morning, everyone. I'm Lexia Weaver, and I'm one of the North Carolina Coastal Federation's 3 coastal scientists. Tracy Scrable and Erin Fleckenstein are the other 2, and you've already heard from them, and you'll hear more from Tracy a little bit later today. I am based out of the Federation's headquarters office in Ocean, North Carolina, more commonly known as Newport, North Carolina, off of Highway 24, where I also manage the Federation's Central Regional Office. I work on the design, the permitting, and the construction of living shorelines from very small scales to very large scales on both private and public properties along the central coast of the state. And primarily I work on the planting of salt marsh grasses and using bags of recycled oyster shells, as you kind of see in that first photo on here on this intro slide. With our partners, we're also exploring and testing the use of a variety of other living shoreline materials for construction, including Sandbar Oyster Company's oyster catcher material, which is shown in the second photo there, photo by Clammerhead Davis Cessna. Recently, I've also been involved in the construction of several large-scale, high-energy living shorelines that use granite stone, as shown in the last photo. Yeah, I'm gonna have to use the numbers. Okay. So this morning, Tracy and I will be talking to you all in more detail about the actual implementation and construction of living shorelines. So getting the structures built and then planted landward, as well as the process of securing the materials and getting your equipment together. So as some of you can attest to already, I want to start off by saying that building living shorelines is not rocket science. And also there are very few locations in North Carolina where a living shoreline would not work. And you kind of saw that, at least for Carteret County, during Laura Eddy's training presentation last week through her the Living Shoreline Explorer tool. So a lot of the areas on there were either green or yellow, which suggested either planting alone or hybrid techniques. So which is a great position to be in for living shorelines. So their design is also already basically created for you in a sense in the CAMA general permit conditions. They tell you how far offshore, how wide to build the structure, how high you can build the structure. And Tara McPherson, she did an excellent job last week explaining the permit process, both for CAMA general permits and CAMA major permits. And both processes also, they are incredibly easy right now compared to how they used to be years ago. So we definitely appreciate everyone's efforts and the state's effort on getting these permits streamlined for living shorelines. So what is limiting living shorelines right now in North Carolina is basically the awareness of this awesome technique, right? Um, and we thank you all like well in advance for recommending them to property owners and for building them instead of bulkheads and seawalls. And then for all of the reasons that we discussed in the two previous training sessions, including their ecological benefits, their resilience, and their cost effectiveness, our goal is to make living shorelines the go-to approach for shoreline stabilization in North Carolina in order to be able to protect our and restore our productive estuaries. So I want to make the session as interactive as possible. I know it's kind of difficult. So let's start off by opening it up and asking you all, what are your concerns and your questions regarding building living shorelines? And that way we'll know them up front and we can either address them throughout our presentations or we can address them right now if it's something I feel like I'm not going to cover through my slides. So don't be shy. I hate giving PowerPoints. I'd rather be conversational. So let's have a quick discussion. Anyone? Any questions, concerns that you have come across? I'll give out prizes in the form of chocolate when I see you next. Crickets. Okay. We have a few minutes. Anything in the chat, Whitney? Okay.
Oh, yeah.
Well, hopefully as we get going and start talking about these things, maybe something will come to mind. I know it's hard with these webinars to be interactive, but we will try our best. I think a lot of our fruitful interaction is gonna come during those field training sessions. Okay, so we've already discussed, you've probably seen the slide in previous other days, the various shoreline stabilization techniques that can range from just planting alone to also placing the wave dissipating materials, such as biologs, oyster shells, and rocks waterward of the vegetation for the edging, the sills, and the breakwater hybrid approaches that you see there. And then all the way to the revetments and bulkheads being the grayest and the hardest shoreline stabilization technique. In my opinion, so this diagram can also be interpreted as the higher the wave energy condition, the more gray my shoreline stabilization solution needs to be. And I don't think that's the case. So living shorelines can be constructed and are effective also at higher wave energy conditions, provided that the structure is designed correctly and according to the conditions experienced at that specific site. So for example, in higher wave energy conditions, you can build the sill wider, higher, with heavier materials that will dissipate that higher wave energy conditions that are experienced at a site. And these higher wave energy projects, living shoreline projects, they do typically involve a more complex design by either consultants or engineers. As Tara pointed out, that they are done through the CAMA major process. So it can be done, and we've had success building living shorelines in high energies as well. So the take-home message to me from this diagram is that living shoreline approaches should be considered first before any of these gray approaches, regardless of wave energy conditions. But of course, you're going to have those sites where, unfortunately, because of existing water depths, for example, if it's too deep, the severity of the erosion escarpments, if you have like a big bluff already developed, the proximity to navigation channels. So all of these are, unfortunately going to make living shorelines a big challenge, and revetments or bulkheads, will have to be the choice in those areas. So this module this morning will provide more information on the use of vegetation, loose or bagged oyster shells, oyster domes, native limestone, granite, wood or vinyl sills, as well as a number of the commercially available precasted structural alternatives for living shoreline construction. Before I move on, does anyone have any comments or questions? Interaction? I think you all need more coffee. I had a lot, can you tell? Okay. Um, so I'll move on. Sorry, I keep going backwards. Okay, so let's start with the plantings. For living shorelines, you'll primarily be focused on planting this regularly flooded and irregularly flooded area that's shown in this graphic. In a moment, I'll show you the typical native species that are planted, photos of these in these zones that are planted landward of sills. However, there's going to be times when the property owner may want or need to plant throughout the entire upland to wetland profile. So it's recommended to plant only native plants as they're resilient, they're hardy, they're resilient to these local climate conditions and are very low maintenance. Um, Along estuarine shorelines, these plants will be exposed to storms, saltwater and freshwater inundation, drought conditions, intense sunlight, and very windy conditions as well. So they must be able to adapt and grow in these varying conditions, as well as in the sandy, nutrient poor soils that are typical of estuarine shorelines as well in some locations. So to ensure planting success, we definitely want to make sure that you're using the most healthy native plants that you can with actively growing roots, and you want to plant them along the profile that's shown here in the zone that is specific to that plant species and their salinity requirements. And you also want to plant them at a spacing specific to each species. For example, trees are going to be planted more far away from one another versus marsh grass plugs. And I'll show you that in a moment, which we'll want to plant closer together. So there are two good references in your manual for planting estuarine and coastal species in the state, and they are titled Seacoast Plants of the Carolinas and Common Plants of the Mid-Atlantic Coast. So you'll find those references in your manual. So starting on the left of this graphic, living shorelines can include the restoration or protection of riparian buffer native vegetation, including native grasses, the scrub shrub plants, and the trees. The gradation between these aquatic marsh and upland zones is really important in providing erosion control and in maintaining the estuarine ecosystem. And in addition to the native shrubs already mentioned, trees such as these bald cypress, the live oaks, and sand live oaks, pines, sweet gums are found in this riparian upland buffer area. So moving on to the high marsh zone, this area is generally flooded only during above average high tides. So the plants that live here, they're adapted to avoid just severe salt stress. The typical species include seaside asters, several species of panicum grasses, sea lavender, etc. So native shrubs such as Yopon holly, wax myrtles, and marsh elder are also found in this zone, and they're effective for erosion control, storm resilience, and they provide great habitat as well. So then we move on to this mid to high marsh zone, I guess around here, which lies above the mean high tide line. And plants that live here can tolerate flooding, but they do prefer drier conditions. And the species that you'll find here are the salt meadow cordgrass, which I'll show you soon, the seashore saltgrass, as well as some sedges and rushes. So some of the more grassier types of plants. And then moving on to the low marsh tidal zone, this is where you're going to be focusing most of your attention. This is flooded daily. It's the intertidal zone, and it's exposed at low tide. So in North Carolina, most salt marshes, like in this area, include smooth cordgrass and black needle rush species. In fresher marshes, you can find giant cutgrass, water millet, sawgrass, arrow arum, or other swamp type freshwater species. And again, this low to marsh area is going to be the one that you're mostly going to be focused on for living shoreline projects. These are just a few examples of the numerous native shrubs and trees that can be incorporated again in both saltwater and freshwater environments in that riparian upland buffer zone. So they include wax myrtle, marsh elder, Yopon holly, and Atlantic white cedar. And these species, they reduce flooding, they help to stabilize the soils, they provide shade, and they offset the effects of climate change, which is also really important. In North Carolina saltwater marshes, three marsh grass species are going to be the main ones. They dominate the landscape, and they're going to be the main ones that you're going to plant for living shoreline projects. The first, which grows in that intertidal zone, is what I will probably call Spartina alterniflora. With throughout this presentation, the name was recently changed to Sporobolus alterniflorus. Um, and I believe, the rumor is it that the scientific community is still going to refer to them as Spartina alterniflora. So we're just going to go with that. So again, this is this intertidal species. It's planted below the high tide line, closer to the water. Juncusor marianus is the next one. It's black needle rush, and it grows close to the mean high water line. And then you have your Spartina patens, or salt meadow cordgrass, that grows also just above the high tide line. But basically, this smooth cordgrass, this is the one that it's going to be often the most that you are going to plant for living shoreline projects in the intertidal zone. These are some examples that I'm not very familiar with. I work mostly in the saltwater environments, but these are the freshwater marsh plants. They include water millet, sawgrass, pickerel weed, three square, and soft stem bulrush. So you'll want to pay attention to the salinity regime that you are in when selecting your living shoreline plants. So this is a great guide. And I'll confess, I haven't seen this before this training, which is, I shouldn't even be saying that, but I wish I would have had this before. But now we all have it, which is great. We are all learning through this process. It's a great guide. It was prepared by Ellen Kalalny from Wetland Plants Inc. So thanks, Ellen. It basically tells you which plants should be planted within each salinity regime. And then it contains specific information on the common marsh grass species, as well as the flowering plants that are used for living shorelines. And this could be a great guide to give to the private property owners that are interested. A lot of them are interested in, what can I plant that's flowery? And so this is a good guide to give some color to their shoreline as well. So this is included in the manual, I think right now on pages 153 and 154. So all of the plants that we just talked about are available through commercial nurseries in North Carolina. And listed here are the primary growers that we typically buy from. And then these are for salt marsh plugs specifically. And plugs of smooth cordgrass and salt meadow cordgrass, they currently cost between 60 cents and $1. And this is going to depend on the nursery and your delivery cost as well, how far away you are from the particular nursery. Less commonly grown marsh plants, such as black needle rush, they are also available, but their prices are typically a little bit more. And Spencer Rogers also, thank you, Spencer. He worked to compile this list of marsh grass plant suppliers in North Carolina. And then there's also a few out-of-state sources, and this can be found on page 157 of the manual.
Lexia, can I add something to that?
Yes, please.
I just wanted to mention to folks, if you are using out-of-state suppliers, which sometimes we have to do for projects for availability, it's always great to ask if they are using seed stock from your state, your region, because of the issue of not really wanting to import species that are not typically found here are native or at least naturalized. So just something to ask if you're working with out-of-state suppliers.
Yeah, good point, Tracy. Anybody else has any other experiences or anything they want to share? I'm trying, Whitney. I'm trying.
And we'd love to have other sources. If anybody on this
Yes.
training has other sources, we'd love to hear them.
Yes, excellent. Okay, so now that you know who sells them, so how do you go about securing your plugs? So I'm always asked, especially by private property owners, well, can I harvest them from another marsh and plant them over here on my marsh? And maybe my neighbor can spare some. But the answer is no. So these, they can't be harvested from other places and transplanted because they are wetland plants in areas of environmental concern. And as such, they're protected and regulated by the Coastal Area Management Act, also known as CAMA, who we've referred to. So the good news is that you don't need a permit to just plant marsh grass from commercially available or commercially grown nurseries. So that's the good news. But the first step is to order them from the nurseries, and you want to place your orders in the fall, September to October. This is really important because it gives the nurseries an idea of how many seeds to collect, so that they can have them ready for the following spring. This is when the smooth cordgrass puts out their seeds in the fall, and the growers collect the seeds in the field. They place them in the refrigerator until about February or so, and then they're planted in soil in trays, and they're grown in a greenhouse with a variety of secret mixes that some nurseries will share with you and some won't. Um, they are usually ready to plant in April and May. It's to me, it's been kind of a struggle to get them to have them available during that time. And that's the time when I really like to plant because once you get into June, it starts getting a little warm and too late in the growing season. So if you can give them also a timeline when you want your plugs, it's really important so that they have them for you earlier in the season, and that so they'll be taller and they start sowing them earlier in the year rather than later. Um, so the best time to plant, again, April, May, start of the growing season, and it's possible to plant them in the summer months as well if you get it in bind, but this really shortens the time that they have to establish their roots, and it increases the chance that they'll be needing to be replanted, especially if we have a strong storm season in the fall where they're not completely established yet. So like establishing any new turf, marsh plants, they need to be managed and watched until they become established. So it's common that additional plants need to be planted in years 2 and 3 in the spring until they become well established. Some sites, as I'll show you in a minute, they take off after year 1. So it just depends. So when they're delivered, depending on the nursery, they'll arrive in either trays of 50 or 75 plugs, or in boxes sometimes. These are boxes of 250 shown in the slide. And there are pros and cons to each of these delivery methods. When they're delivered in trays, they take up more space on the ground. So you have to have more space to stage them before you plant them, but it gives you a little bit more time to plant them because you can easily water them and care for them directly in the trays. When they're delivered in boxes, however, you do have to take them out of there as soon as possible and water them. It takes up less space initially, but you kind of have to plant them pretty soon, so you have to plan ahead for that, since they can't be watered easily in those boxes. Sometimes also when the plants come from the nursery, some of them are very tall. And what we noticed when we planted them is that they kind of drooped over. So what we've been doing is giving them a haircut or clipping the tops so that when you plant them, they'll be standing straight up and not flopping over. And that has been successful. So if you have a greenhouse, you can also grow these plants yourself. We've done it before through our student wetland nursery program that we used to have. So it's not difficult to do and can, save you a lot of money. Or you can also start selling them on your own as well. So the best time to plant, as I said, is in the spring, April through mid-June at the latest. So sometimes it only takes one planting for the marsh grass to be established along a shoreline. But depending on the site, it can take up to 3 years of successive spring plantings for full shoreline coverage. So if you're putting in a sill, it's best to wait until the sill is in place before planting the grass. That way it'll be protected right away with that sill structure, and it'll increase your plant survivability. If you're planting a shoreline that has no existing salt marsh, like the one shown in this photo, for example, where would you plant each species? Anyone? So let's say you only had 300 plugs. Where would you plant them along this 100-foot strip? 300 is not a lot, really. They're tiny. All right, so you basically, I'm going to continue. Y'all are cracking me up. Okay, so the easiest way is to follow your high tide line, right? So smooth cordgrass is planted in the intertidal zone. From the average high tide line to the average low tide. So you don't want to plant them too deep in the water as well, because you don't want them to be submerged all the time. They're an intertidal species, so they'll be exposed twice a day and underwater twice a day. And then salt meadow cordgrass and back bonito wash, you'll plant that above the average high tide line. So if you're planting in an area where marsh is already present, like here, it kind of tells you the zones already where to plant them. So you would plant your alterniflora where the alterniflora is growing, and then your patens and juncus where they are growing. So that's easy. If you can only afford about, like I said, let's say 300 plugs, you don't want to plant them all along the length of the shoreline. You want to plant them as close as possible. And we found that this is the best success rate for plugs. So we want to get them in there about 6 to 12 inches apart. They survive better when they're closer to each other. It's like safety in numbers. Over time, this patch will spread and get bigger. And then the following spring, you can plant another 300 plugs. And over time, it'll spread naturally as you plant more plugs. If you had 3,000 plugs, then you can cover your entire shoreline, because you can plant them all really dense and really close together, and they'll do a great job. So I always like to tell the story. We didn't used to plant the plugs like this. So traditional planting protocols had you plant them based on 2-foot or more offset centers. And so one day we had a group of student volunteers. They're on a field trip. They don't want to work. They wanted to just hang out with their friends. So they sat down and sorry for all of you who've heard the story already, but they sat down and basically planted an entire tray in one little spot, right? So I'm like, great, I'm going to have to come back here. I'm going to have to replant these plugs. Well, sure enough, we come back and these were the tallest. They were greener than the ones nearby that we planted. So ever since then, we plant them as close together as possible as we can. Okay, so again, not rocket science. These are planted very easily. They're planted at low tide with the use of these commercially available orange dibble bars, and you can obtain them from forestry suppliers. They have gone up a little bit in price. They're now about $50 each. And so basically the dibble bar is inserted into the soil, and it's pushed back and forth, not side to side, and it makes this 6-inch V-shaped hole right in here. And then I'm not a big fan of using fertilizer. I've found through the years that it's not really necessary unless you're planting in really sandy soil or clay. Typically, there are enough nutrients in the ground to support the growth of the grasses without fertilizer. But if you decide to use it, you include approximately 1 teaspoon to about a tablespoon or so of this Osmocote, which is a slow release fertilizer. You put it in each hole. And then if you're planting underwater, which can be an option, it's really hard to use fertilizer because they're just these little pellets that float. So you don't want to use fertilizer when you're planting when the tide is high, because it will just wash away. So it's really important, and I can't stress this enough, is to plant each plug deep enough to avoid losing them when the tide comes in, and from high energy and wind events, until the roots get established. So it's generally recommended so that each plug is planted at a minimum depth of approximately 2 inches above the plug that you're planting. So don't be afraid to stick them in there, even though some of the green is under the hole. So if soils are very sandy and they're relatively free of roots, stones, or heavy shell hash, it's also possible to plant these grasses using battery-powered augers. So basically, you kind of drill your holes instead, and then you want to choose the diameter of the auger bit to give you plenty of room so that it helps you plant the marsh grass plugs and helps you get them in deep enough. So planting the plugs, it's really easy. It's an activity for all ages. It can be time consuming, especially if you're planting thousands of them at a time. So it's best done in teams of at least 2 people, with one person doing the digging and the other person following behind and filling in the holes. When planting with large groups of people, it's important to provide guidance and quality control to make sure those plugs are planted deep enough and close enough to each other. And care should be taken when stepping around the planting area so that you don't step on and damage the newly planted grasses. So that's really important too. Some obvious things, but just some things to remember. These are before and after planting pictures that were taken at Jones Island in the White Oak River near Swansboro. After 1 year, you can see that the marsh has established itself quite nicely. We didn't have to replant this marsh. And then part of the reason was because we put in 9,000 plugs in this 250-foot linear feet of shoreline. So the more plugs you can plant, the quicker your marsh will become established. This shoreline, which is just on the other side of the island, took longer to establish. We had a greater area to cover. We had 60 feet as opposed to like 20 feet. So marsh establishment, it's going to vary between shorelines depending on the width of the shoreline. So this one was planted for multiple years with thousands of marsh grass plugs till, it kind of got completely established and, you don't see the spacing in between them. So it just depends on site conditions and the number of plugs that you put in. So we're going to move on to using recycled oyster shells for living shoreline construction. Before we do that, anybody have a question about plantings, or maybe there'll be some time at the end to discuss?
So Ted has a question in the chat box. Do contractors need to hold plants with nurseries over winter to ensure enough supply for their planned anticipated projects?
That would be wise of them to do, yes. Especially if they don't get them all sold. And then, Ted, good point, because if they do save them and overwinter them, it's a little bit of maintenance. They have to take care of them over the winter and everything, but in a greenhouse. But next spring, they'll be available earlier for us practitioners to use when it's ideal to plant, and the plugs will be established more. Like their root systems, when they're overwintered, they're 100% like thicker and more established. It's hard to get them out of the trays because they kind of go through it in and out of the trays. So yeah, good point. So yeah, it is in their best interest to overwinter them. And if you can buy ones that have been overwintered in the greenhouse, that would be even better.
And Lexia, too, as you pointed out before, when you get them overwintered like that, you're almost always having to cut away the roots below the plugs. It doesn't hurt them. And also you need to give them that haircut you talk about so that they're
Right.
Not being pulled out physically by the tides. And also it stimulates the new growth of the rhizomes, root systems.
Yeah, they can come definitely pretty much taller than the normal just seedlings that have just grown. So yeah, good point, Tracy. I know you can't really hurt these plugs. They're very hardy, which is a good thing. Anybody else? Planting questions to the oyster shells? Okay. All right. So recycled oyster shells. So they are the shells of oysters that were harvested and consumed. Each oyster has 2 shells, and once the inside of the oyster is eaten, the leftover shells are collected at recycling centers. And these recycled shells are eventually put back into the water to create habitat for more oysters. and to protect shorelines from erosion. Oyster shells are the best and most natural material to use to build oyster reefs and living shorelines, but it's also in short supply. And to save this ecologically important byproduct, the state of North Carolina and other organizations had previously managed oyster shell recycling programs. Unfortunately, the state had lost funding for this program, and only small scale recycling efforts, such as the one managed by the Coastal Federation, are currently in place in the state. Um, Oyster recycling drop-off locations, they can be found throughout the coastal region throughout all of the coastal regions of the state, and more information on where these are can be found on the Coastal Federation's website. So using recycled oyster shells, it's a great option for living shorelines. It takes a resource that would otherwise be disposed of in a landfill, and it puts it back in the water, where it provides a hard and preferred substrate for new oysters to attach to and grow. It provides reef habitat for fish and crabs and shoreline erosion control, which is all of the ecosystem services that we're interested here. So the new oysters, they also that attach and grow, they also help to improve water quality, because as they feed, they filter the water. So where oysters grow naturally within North Carolina's estuaries, recycled oyster shells should definitely be considered as an option for living shoreline projects. While they can grow throughout the tidal regions, they're best adapted to higher salinity conditions, as opposed to the lower salinity upstream creeks. As a rule of thumb, if oysters are visible, they're growing, thriving in the area of your project site, it's a good indicator that oyster shell recycling projects and that technique is appropriate for that area. So you can look for oysters growing on rocks, on docks, or other hard surfaces, pilings that are adjacent to the marsh. So that kind of gives you an idea. So unlike just planting a shoreline, so the placement of oyster shells in the water in any form does require a permit from the North Carolina Division of Coastal Management. So oyster shells are used for reef restoration and living shorelines in a variety of ways. Loose oyster shells can be placed just waterward of the marsh to stabilize the shoreline, like what was done here. And they can also be placed a bit offshore to create patch oyster reefs, which help to reduce wave energy and protect shorelines as well. The oyster shells can be put in mesh bags right here, and they're placed either right up against the eroding shoreline or a few feet offshore as a marsh sill. And in coastal North Carolina, the use of loose oyster shells for living shorelines, it may not be suitable along shorelines with high to wave energy conditions, such as those that have strong and frequent boat wakes, winds from storms and hurricanes. So in these conditions, the loose oyster shells, they can move and scatter before oyster settlement and reef establishment occurs. So just a little bit of warning with that. So currently recycled oyster shells can be purchased from seafood companies, such as Quality Seafood in Elizabeth City. They cost about $3 per bushel, not including transportation. And again, it just depends on where you are and how far the truck has to travel to deliver the shells to you. You can also get oyster shells from large oyster roasts, like those that are held by the local Rotary clubs, or they can be donated or purchased from restaurants as well. So for the lower to moderate wave energy environments, loose oyster shells, they can be used for living shoreline projects. In this case, recycled oyster shells are placed along adjacent to the marsh grass. They're placed to replicate the natural height and formation of naturally occurring reefs. So then these restored reefs are created as mounded reefs, and they're shaped into a more natural reef with the subsequent tides that come in and the erosion forces. And to be successful, they must attract natural oysters to recruit along the newly established reefs, which anchors the structure in place and provides this sustainable natural element of living shorelines. So as with all living shoreline methods, you need to consider your shoreline site condition. If it's in a high energy site with lots of sand movement. You'll need to bring your reefs higher to prevent them from getting covered by sand. In areas with high wave and storm erosion potential, the loose of oyster shells, it just may not be suitable for the establishment of living shorelines or reefs. So there is a sweet elevation spot where the shells must be placed. And to guide your reef design, we use existing low and high elevations of oysters that are naturally growing in the area. So, for example, along those pier pilings, other hard structures. And then one thing I want to point out too is that in high salinity areas, you want to place your oysters in the intertidal zone, because if they are submerged all the time, they may be subject to what the scientific community calls the pest, such as the boring sponge, which they basically bore into the shells and break the integrity of the reef over time. So the distance offshore that the shells are planned to be placed, as well as the size of the oyster shell footprint, determines whether a general or major CAMA permit is required. If the distance is greater than 30 feet from mean high water and the base width of the footprint is greater than 12 feet, the placement of loose oyster shells or patch reefs for living shoreline construction, it does require a major CAMA permit as opposed to the general one. And this is just an example of a design that was submitted for patch oyster reefs through a CAMA major permit application because of the distance offshore and the footprint. For small homeowner scale projects, these types of designs are sufficient. However, when you have much larger and more complex shorelines, the plans may have to be developed by either a consultant or an engineer, which some of you are on this webinar today. So for this particular project at Jones Island and the White Oak River, it just consisted of creating 5 staggered patch reefs. Each were approximately 1 foot in elevation, and the reefs received about 1,500 bushels of recycled oyster shells, and they are pretty much subtidal most of the time, but it is a brackish area there. Loose oyster shells, they can also be placed along shoreline using small floating platforms or barges and a power wash system, such as those used by marine contractors for jetting in docks or pier pilings. And once these shells are placed, the tides, the waves, and the currents, they'll reshape the mounded shells into a shallower, broader shape that's suitable for oyster recruitment and growth. So if it really in North Carolina, in my opinion, if you wish for the shells to remain in place where you place them, we've had a lot of high wave energy. It's very rare to find these calm conditions, except unless you're up in creeks. It's necessary to contain the shells, and we do that using mesh bags. And these mesh bags are stacked in layers. They're placed perpendicular to the shoreline so they don't roll. And they're placed along the length of the shoreline, so parallel to the shoreline, and you can create marsh tow revetments or marsh sills. And then both of these help to dissipate that wave energy and reduce shoreline erosion. So to make these bags, we use mesh, PVC tubes, and this specially designed bagging frame. And the mesh costs about $125 a roll. I think there's about 200 feet in there. The bagging frame can be built using either wood or metal. This is a wooden one, a metal one here, sorry. So I know you all are going to ask. So the mesh, yes, the mesh is unfortunately plastic. And it is used for living shorelines here in North Carolina, in Florida, South Carolina, Delaware, and other states. And all of the living shoreline practitioners that use this material, we realize that it's not the best material to use, in that we are essentially adding plastic into our estuaries. But these and I will say but, these mesh bags, they work incredibly well for living shorelines. They stay in place even after strong storms. We had Florence, they were still there after the storm. They slow down wave energy, they reduce erosion and restore the valuable salt marsh habitat and oyster habitat that has been lost, or protecting existing habitat. They're volunteer friendly. They recruit oysters. They turn, so many reasons, they turn into productive oyster reefs in which these bags are no longer visible. Again, they do well with hurricanes, and they've done better than the adjacent bulkheads and seawalls for sure. In the very rare occasion that the bags do tear, the good news is that they don't scatter into tiny little pieces. They kind of stay together, and you can easily clean up and remove the broken bags from the site. So the Coastal Federation, as well as many other organizations, we've been trying to find this degradable mesh that lasts at least 3 to 5 years, in order to allow the oysters to attach to and grow and give the reefs time to get established before the material degrades. And we are also looking into, kind of going in the reverse, and we realize that, but stronger plastic mesh that would not be damaged in areas, for example, of high wave energy, or in areas where these living shorelines could potentially be harvested if they are in open oyster harvest areas. I'm not opening up to questions because I'm kind of running out of time. So I'm just going to continue. Okay, so to make these bags, the first step is to cut the mesh, which comes in a roll into about 3 to 4 foot sections. A knot is then tied at one end, and then we turn the bags inside out so that the knot is inside the bag, so that we don't have this kind of tail at the end. The tubes, they're then placed into the bagging frames. As you can see here, these are wooden bagging frames. And then they're filled with recycled oyster shells, either using shovels or equipment, such as this large dumping bucket. The tubes are then removed, and what you're left with is the oyster bag, which is knotted on the other end. And then you have your final product, and these are stockpiled until they're ready to be transported and deployed into the water to make your living shorelines. So because of the short supply of oyster shells, you can substitute oyster shells with limestone marl, especially for the bottom layer of the structure, which typically recruits the least amount of oysters. So limestone marl, it can be purchased from local suppliers. For this size of marl that you see in this photo, you can get them from local septic companies. So ideally, you want to make the bags at the site where you'll be using them, and this will minimize the number of times that you have to move your bags. But sometimes this isn't possible, and they need to be transported to your site either by trailer or by boat. So sometimes it just, because of the nature of where the site's located, like on an island, for example, you do have to move your bags multiple times. So if you're not going to place them in the water right away, you need to find a good stockpile location as close to your shoreline as possible, but in the upland area above the high tide line. So you can't place anything in the water until you are ready to build. So here's some photos of eroding marshes that are excellent candidates for oyster bag marsh tow revetments. They are lower in elevation. They're fairly uniform with respect to their escarpments. So you basically put the bags right up against the shoreline to protect the existing marsh. This technique does not restore lost marsh. It basically just protects what you have left. So again, if you're looking to reestablish your marsh, this design is not the preferred method. Instead, you would do an oyster still. This is just a cross section. I think we've seen these before in previous presentations, showing the placement of these oyster bags along the escarpment. And it's important to get that slope accurate, and at least a minimum of 1.5 to 1, because you don't want to make it a wall which would cause scouring in front of the placement of your bags. So for a marsh tow revetment, this is an example site plan that can be submitted with a request for a CAMA general permit. It's information. It can also be provided as a hand-drawn sketch. So we just do it on the computer just because it's easier, and you can use kind of the template for multiple projects. Just kind of the important thing here is to kind of show where the project is relative to other towns and water bodies, and to more or less indicate the footprint of your sill or marsh tow revetment. And this is the design that we submit. Again, not engineered. It could also be hand drawn, just kind of showing your dimensions of the structure and relative to normal or mean high water and low water and where the existing marsh is. So these photos are, they show a marsh total revetment being constructed by volunteers from the community, a lot of them. And it takes a village sometimes. So it just kind of shows the placement of the bags right up against the shoreline. Over time, it helps to protect this marsh and will also recruit oysters waterward of the bags. So this work can also be done by local fishermen as well as other work crews. They can be hired on a temporary basis, especially during their slow seasons, which is great because this restoration of these living shorelines, it could lead to jobs, and it basically is a great way to help the local economy. So always consider that as well when building these. And I think this is my last slide. So for the project pictured here, we built it by these two local fishermen built it. They placed 4,785 bags of oyster shells in about 17 days. And this was at Beacon Island near Ocracoke, just to give you an example of what it looks like. And this is what it looks like immediately after construction. So you can see the bag. The shells are still white. They are not, haven't recruited any oysters just yet. So I think I have a few minutes for questions and comments, if anybody has any. You all have been very quiet.
So Tracy and Ted have both made comments in the chat box. If either of you want to expand on that, you're welcome to.
This is Ted. Just two things to emphasize what Lexi said regarding the marl. It's definitely available. You can also use granite. Sometimes that's cheaper depending on the source. That we usually work with a hauling company. They source it out of local quarries. They can deliver it pretty easily. You do have to be careful with the dust, though. It's you need your workers or your volunteers to be wearing masks with the dust. Then the only other thing I mentioned is just if you want to temporarily place your bags or any kind of construction materials within the 75-foot or 570-foot CAMA buffer, you need to clarify that as you apply for your permit. Otherwise, you won't be able to temporarily put those in there. And Tara can confirm or deny that if that's correct, but you want to sort of make sure you got everything up front. That way you don't have to ask at the last minute and try to get permission to do that. Thanks.
Hey, good morning,
Lexi,
Lexi.
go ahead.
Hey, I was just wondering if you guys had found any configurations of placing the oyster shell bags, certain ways that work better than others. I see in the photo here. I can't really tell how they're stacked, but is there a better way or efficient way or different ways? Does it matter? Just wondering if you could talk about that for a second.
Yeah, absolutely. So for marsh shore revetments, we again stack them up against the shoreline. So we do 3 bags 3 bags out and 3 bags high. Sometimes it requires more bags depending on the height of the escarpment here. And it also depends on your wave energy. You can go up to 6 feet in width, depending on the wave energy conditions. We found that 3 bags, it gets you to about 4 to 5 feet wide. For sills, and I don't think I have a picture of it, maybe Tracy does. We used to do them 3 bags high and 3 bags tall, but lately we have fixed our slope a little or a lot, and now we are doing them 4 bags across, 3 on top, and then 2. So 4, 3, and 2. And that gives you the slope, a better slope to reduce that wave energy. So it's more of a trapezoidal pyramid shape, if you will, that helps dissipate that wave energy a little bit better. So that's the current way. We're always learning new ways. I know in the Southeast and like at Morris Landing, it's a higher wave energy condition. So, Ted can speak to how he built his. I believe his are a little bit wider than what we build them here on the Central Coast, and they use marl, whereas we don't as much here in the Central region. So.
A couple other things. I mean, as Lexia said, these structures can be modified based on your energy, your slope, your sites. Two things that she said that I'll emphasize: those bags should be placed shore perpendicular rather than sort of parallel to the shore, and that is because they roll if you place them shore parallel. So perpendicular. Also, as you stack the rows from the bottom to the top, we place the next row of bags in the seam between the two bags that you've placed on the bottom layer. So you're offsetting, you're not placing bag right on top of bag so that they hold into that space more tightly. And you can see that. And yes, we will show some more photos and talk about some specific projects of these designs in the next segment, but that's a great question.
And this is Erin. I would also just emphasize that, making sure you have good oyster growth is critical to the success of these structures. In the Pamlico Sound, we have a lot of areas that may not be conducive, either because of exposure or because of a lack of oyster growth. As you get sort of into the fresher brackish waters, we don't have great oyster growth. So don't promise an oyster sill until you know for sure the oysters are going to grow there.
And sedimentation can be a real issue in some areas, lack of circulation, even in areas where we've got the correct salinities. You kind of have to do a little bit of sleuthing to see how native oysters are doing along your sites.
There's a seasonality to planting the marsh plants. I know there's a seasonality to when oysters recruit in certain areas. Have you seen that putting out oysters at a certain time is better, or do the oysters stay in the bag still enough that the seasonality isn't as important?
Here in the Central region, we place them year round, and they don't move. They'll just, but we have so many projects going on, so we take advantage of that winter season to get more projects in the water, and they stay there. So then when that water temperature gets warm enough and the larvae start swimming in the water and getting ready to attach and grow, the bags are already there. And they don't get, again, sedimentation could be an issue in some areas, but as long as it's not an issue and they don't get sedimented, which is rarely the case, the surface is there for the oysters to attach to and grow April through October when when it's the recruitment season. So I think it's pretty similar in the other two regions as well.
I'd say yes, and Ted can speak to this more, but we can have larval attachments in a fall event and a spring event, and it just seems to be variable. So the only caveat here is if you put them in and we get a Category 4 hurricane and they haven't had time, then you've got an issue. But prayer is really kind of important in all of that. I think we've been lucky.
This is Erin. We've also built them year round, but I would say that if we don't have a good recruitment season, if there's too much algae growth over the winter, that can be really problematic to the spat set. So we prefer to do it in the spring and summer than winter.
One last point before we go to break, just like any other project that you're building, it's quality versus quantity. We built a living shoreline just a few weeks ago, and we had 4 of our marine debris crew working as contractors, and they built a lot of it. We had some volunteers help, but they built it in a short of about 3 days, and they did it very carefully, and that's going to lead to your ultimate success, just like building a pier or any other structure. If you take your time, you do it well, you're going to have a lot more success versus just throwing a bunch of bags down, nestling together, locking them together as you build them, kind of. Those are all things that take a little bit extra time, but they're well worth it down the road.
Yeah, tucking that extra plastic that's at the end, we call it the tail, under the bags takes a minute longer, but it's very useful in terms of that's just when it's out flying around, it's something else for waves and boat wakes to grab onto and possibly roll your bag. So we really try to pay attention to that too.
I was curious also about the recycled shell in the centers that the Coastal Fed runs, and how available is that shell to other contractors when building living shorelines, or is that shell primarily used by the Coastal Federation?
In the southeast region, the shell we make available we sell to the Division of Marine Fisheries. And if we have excess after that, as well as our projects, we're definitely willing to sell it, at market prices. So it is available if we've got it.
Is that true in other regions or not? I don't know the answer.
We don't collect enough here right
Okay.
now, unfortunately. I think hopefully with future outreach and education, that we have these sites where they can be delivered, that we'll get more, but we just don't get that much. I know Hammocks Beach kind of generates the most for us right now. People taking them to Hammocks Beach State Park, and then the park will bring them to us, but it's only about 100 bushels. It's not enough to make it so it can be readily available and on a constant time frame to contractors, unfortunately, at this time.
And I would also, go ahead.
I was just going to say, in the Northeast, we're kind of in the same boat. We don't have enough to sell at this point. We're using it all in our projects, but should we get to the point where we're collecting more than we're using, we would be open to selling it, similar to how Ted outlined.
And I would say thanks to Ted, he is responsible for increasing the number of oyster shell recycling stations in the Southeast region. And so we should expect to have even more resource, which isn't the same as saying it's going to be more available if DMF needs more or we ramp up, but it's always worth asking because we have sold it in the past and we'd love to if it's available.
Lexia, we have a question in the chat box from Sarah. She wants to know what the average oyster bag weighs.
15 pounds, say. So it's not too bad. And you can make them bigger or smaller, depending on who's putting them out.
Alrighty, I have 10:46, so we'll pick it back up, and Tracy's going to continue discussing how to construct living shorelines. Over to you, Tracy.
Okay, thank you. So good morning, everybody. You all are serious gluttons for punishment. So really want to thank you all for sticking with us during this pilot training, which is many hours. We hope it's been useful to you. And please do feel free to jump in during my session. There are many folks on this call that can add value to this conversation. So we want this to be interactive, as you've heard. Also, I want to put in just a quick pitch for the field trainings. In June, we're going to be going to Morris Landing, which is, you'll see in my slides. And we have at least 5 different techniques to look at and talk about. And I also plan to have some of the precast product out there. It is not one of our projects at this point, but I'm asking those suppliers to just provide it so you can see those as they're commercially available. So we encourage you to sign up for that. So what I'm going to do today is really sort of jump in to where Alexia has led to and continue with the different design options, providing a little more detail where appropriate on these in terms of design, but also on cost. And I say that with a giant caveat because the cost is a moving target. And some of these costs, every slide says cost are variable, and you all know that in the business, but with COVID, some of the material costs have really gone up. So we're trying to just give you relative costs, so bear with us. So I'm going to pick up here and just spend a little more detailed time on some of these sill designs, and I'm going to start with stone sills. So as Lexia said, stone sills are really a great choice where you're in higher energy regimes. The old school of thought was when you said living shorelines, you really meant no or low energy to moderate energy, and you still see that written, but it's just simply not true. We can put living shoreline projects in high energy environments. Now, having said that, you need to really pay attention to things like what your bottom substrate is, and can it withstand the weight of that material in that shape, and I'll talk about that shape in a minute. So that's important, and also designing them so they qualify for the general permit for residential settings is pretty important. So, but again, high energy sites, I've included here 3 different types here, or 3 different areas, and what we like about these stone sills where appropriate is that you can change that bottom width, which then as you're building them up, as you've heard, into this trapezoidal shape, really gets you the elevation you need. So we like this design. There we go. So I've included 3 slides here on your left. The top one is the Pine Knoll Shores Aquarium, and that's a higher energy regime on Bogue Sound. In this case, the aquarium, we worked with the aquarium on this, and the design for this was to maintain that marsh in it was eroding primarily from storms and boat wakes, and so we held the marsh, if you will, but also they were getting a great deal of erosion right around the pier itself, and that's where their water intake lines were. So the design here was to withstand relatively high energy and to hold that marsh in place, which it has done. The bottom 2 are in freshwater regimes. The middle one is in Albemarle, and you'll see that design again a little bit later. And again, what we're trying to do there, it's a freshwater system that has been eroded away. Bald cypress is very prominent along this shoreline, and we wanted to maintain that. And then the bottom is on the Chowan River, also a high energy regime, and this is at the Eden House boat ramp, and you'll see more about both of those projects. The value in these is, as you've heard before, very effective for erosion control, but also for resource restoration. So jump right into cost here. And again, feel free to add your thoughts on this, but we're trying to give you sort of from our projects relative cost. And again, some of these are a little dated, but I'll just throw it out here anyway. So and I use a 50-foot linear measure so that you get relative cost between these different approaches. So we calculated from this project for stone sills and marsh tow revetments. Again, I'm giving you a range because a marsh tow revetment can be half the size of a stone sill, but I'm trying to give you relative cost for a typical residential setting, not some of our big projects. So we calculated for a project that we did stone, and that's material and cost, to be about 150 to 200 per linear foot. The plantings associated with a typical stone project would be, we'll say 1,500 for 1,500 plants. That's $1 per plant, and that was true at the time. You'll see in later slides $1.50 per plant, and I would invite Lexia. She's planted about 10 million of these at this point. What the current costs are for the low and high marsh plants, they're variable. So, but for a typical 50-foot section, I'd say 9,000 to 11,500 is a pretty good range. Vertical wall sills. To remind, for those of you that might not have been on the call last week, the sills are differentiated from other approaches for erosion control because they're channelward of the restored marsh or the preserved marsh that you wish to keep in place, and that's what makes them so effective as living shorelines. The vertical wall sills are made usually of wood or vinyl. And again, these are placed in locations where perhaps your substrate is not suitable for stone or oysters, or we don't have oysters. It's a very limited footprint, but it's very effective if you have narrow channels, and it serves the same function as dissipating that wave energy to protect what's landward of that. So they can be quite effective, and you see a typical design there. And then at the bottom, this is one on in Wilmington. Nice project, very low profile, very, very narrow channel here that boats just barely can pass each other. So it was a great choice for this particular location. In terms of their relative cost, again, the one that I used for an estimate was a vinyl installed living shoreline. And we have 8-foot sheets here. Galvanized hardware is important. And then, of course, marine treated whalers. And we estimate about 120 to 140. Again, the size of the structure is relative. And for all of these, the costs are going to be variable based on not just the structural design, but where the site is, the mobilization cost, the demobilization cost, the location, what the availability is of the material and the transport, and of course, current market conditions, so supply and demand. On this one, again, I utilize $1 per plant. So the relative cost of this is $7,500 to $8,500, cheaper than the stone project by project. So the oyster shell bag living shoreline, again, Lexia has talked a great deal about this, and we like this approach very much because of its ability to be designed to fit the shoreline, both in its alignment along the shoreline. You can curve them, they can be linear, the base width can be variable. This is a typical project that has a 6-foot base. We built these with 12-foot base. And again, you scale up the bags, the number of bags, and also the height can be variable. And in this case, you're looking at a fairly typical 3 bags on the bottom, 2 and 2. Again, that can be 4, 3, 2, depending on the site. But this is one of Lexia's site. I think she talked somewhat about this at White Oak River. And this is a 150-foot project by 6 foot wide that was built by volunteers. And because Lexia is brilliant, she understands that when you're having volunteers, you always invite the Marines, always, always, always. And you make sure they're carrying the marl bags, which are twice as heavy as the other. And you can see here why we love this design. Not only does it really mimic what nature provides for erosion control, oysters are magnificent in breaking down wave energy and holding that, that leading edge of your coastal marsh, but they're incredible habitat, not just for other oysters and for filtering the water, but for a number of different fish and all kinds of critters that live here. So you can see this is a very successful project. We are using the plastic bags here, but this is our best case scenario. And I believe we have one of the contractors on the line here that built this particular one. And this is what we're going for when we design these projects. So we're big fans of these. So typical cost, again, for the oyster shell bag sills and the marsh tow revetments for a 50-foot. Try to move my little thing is covering up part of the words here, but anyway, I'll work it out. In this case, we used about 700 bags, which is again $3 per bushel. And in this case, we calculated, thank you, Ted, for this, 14 bags per linear foot. So I think I estimated 6 on the base, 4 and 4 is probably what we use, but I could be wrong. So about 175 bushels, 3 rolls of mesh, as Lexia said, about 125 a roll. The bagging frame to build is probably a wooden one in this case. And again, we're assuming that we're paying someone else to do these bags at $5 per bag, which at first glance, property owners may say, boy, that seems like a lot, but it is not when you consider the effort involved. And it is well worth it for these projects. And you'll see the total cost here is, in this case, at $6,000 or 120 a linear foot. So a very cost-effective approach. And for those of you considering getting into the business, once you have your frame in place and your process down, can be quite, I think, a good business decision. Oyster domes. We've talked a little bit about oyster domes in last week, and these are known commercially by a number of different names. Reef balls, you hear them called, oyster domes. They first came on the scene as oyster reefs and were sunk as oyster reefs. But they're precast structures that are available commercially. We've used a number of these. Ted is an expert in these at this point. And again, in some places, like our friends down in Florida, Tampa Bay Watch, they actually create these themselves. They have a precast little system, and they will use volunteers to pour them and create their own. And then they carry them with a pole through them, and they're smaller in size than the ones we typically use, but it can be done. These are very, very effective as a sill design, and you see a couple of examples here in terms of we've got them two structures wide here. They are available in everything from the size of a Volkswagen to something a couple people could carry. What's important here is that you're placing them in the location where oysters are going to grow pretty much along the entire alignment from the base to the top. It's not 100% necessary, but it's optimal that you are placing them and that you pay attention to shooting those elevations so you know where native oysters are going to grow and we get maximum settlement. Again, a typical cost comparison here. This is one of our projects at Morris Landing, and you see the design here on the right. Ted, as always, hit it perfectly on the elevations here. We've got great oyster growth. And not only do we have great oyster growth, but we've got heavy utilization here by all types of fish and crabs and polychaetes. And so this is both a very effective erosion control measure and also a great oyster reef. So for 150 feet here, again, I'm upping the cost here on plants to be a little more current. The domes and at this time was about $90 per dome. So for 200, we got 18,000. And then you have to factor in delivery, unless you're making them in your garage. And I encourage y'all to think about that. But 1,500 is what we paid in this case for delivery on a truck. And then the installation, we used a contractor to place this in place. I believe he's on the line. I believe Chris Connolly put these on the ground for us. Thank you, Chris. And so total cost here is 27,000. I broke that down into 50 foot, which is $9,000 roughly for a 50-foot section. Again, these are great approaches where your substrate is correct, where you got oysters that will grow within the range that you need them for erosion control. So requires some thought, but an excellent, excellent option. I'm going to run through a number of our projects that you're going to see during the field session. And this is our property at Morris Landing. I say ours, it's yours too. This is a clean water preserve that we purchased from the Boy Scouts 2004, I believe. Ted will correct me. It's 52 acres on Stump Sound, which is our highest quality, one of our highest quality oyster waters in the state. And we purchased this for a couple of reasons. One, to take it out of development potential and the lands around it, but also to provide us with an opportunity to experiment with different living shoreline techniques. And again, when you own property and you don't have structures to protect, you can get a little experimental, a little bit risky, and failure teaches us some things. So we hope you'll join us to come visit this, but you can see more about all these projects on our website here. So I'm just going to run through a couple. So starting back in 2005, our first project out here was a stone sill. that was roughly 600 feet long by 6 feet wide. And what you see on the left here is what it looked like before. Now, there used to be a really nice marsh here, and the reason why there isn't one is twofold. One, there's lots of erosion here. This faces the intercoastal waterway and the mass migration of humans heading north to south and south to north. And so you get a lot of boat wakes here. You also get storm energy. The other reason why you don't see marsh in that photo is because of vehicle traffic. This area before we built a pier out here was heavily trafficked by vehicles. It was basically the wild, wild west when we came on the scene here. And so while it was suitable for marsh restoration, it was currently not growing there. So we constructed a pier that cut off the vehicle traffic, and then we, over the course of years and on the backs of many, many small children, we restored the shoreline. This sill, if you're out there, is a good sized sill. However, the crest on this is fairly low. It is half a foot below mean high water, which can be on the lower end of what you would put a crest elevation for a higher energy site. But we wanted to experiment to see how effective restoration would be at this lower elevation. And as you can see on the right here, and even more so today, it has been very effective. Please do stop me if you have specific questions. So the next project we did here was in 2008, and this was around the corner, if you will, so sort of not directly facing the intercoastal waterway. This is on the eastern shoreline. Interesting, the difference in angle of this shoreline or this reach of shoreline made a significant difference we found in terms of oyster recruitment. I mean, you literally, these two sites are within sight of each other. However, the shoreline that I just showed you facing the intercoastal waterway had much heavier oyster set initially and actually through time. And what we have come to understand is that most likely it is because we don't have the same level of wave energy, circulation, availability of oxygen and food to the oysters, and maybe more sedimentation on this side. So I will let Ted jump in here on that. However, we have learned a great deal about this side, and we do have oyster recruitment. It's just not nearly as robust as on the other shoreline. So where you place them even within sight of each other can make a difference. So you've got 200 feet of shoreline here. This one is 150 feet by 8 feet. So this is one of the slightly wider shell bag sills, and then 150 by 25 feet of salt marsh restoration here, mostly the low energy, the low tide marshes here. So the Spirabolus or the Spartina alterniflora is what we used. And then we put in a little section here of the oyster domes to see how they did in terms of recruitment, and also just to dissipate a little more wave energy right there. In 2011, we did another 225 feet in that same orientation, actually adjacent to the site I just showed you more or less. This is on the northeastern side, so you're going around the bend and moving in a more protected area from that intercoastal angle. However, there's plenty of storm energy that makes its way into this area. This was 275 feet by 6 foot oyster reef, oyster bags, and sills made up of the dome. I'm sorry, these were the domes. I apologize. No, let me take this back. Sorry, Ted, please correct me when I'm going through your projects on Morris Landing. This is on our northeastern side. So we're back in the other orientation here facing the intercoastal waterway. So this is the area where we did 275 foot by 6 foot wide reef sills made up of the oyster domes, and then 75 foot by 8 foot sill made up the oyster shell and marl bags. And then this is one where we played around with depth of the different orientations to see how sensitive they would be to for erosion control. And what we found along this section is that we got oyster recruitment, but the energy kind of came around the end of this site, and we had trouble keeping marsh grass in here for the lower elevation sills. So that was something that we learned, and you'll see that when you're out there. So phase 4 we call in 2013, we added on the southwestern shoreline a 300-foot section of living shoreline. And this was quite variable, again, trying to push the envelope and learn from adaptive engineering and management. Is about 100 feet by 8 foot oyster shell bag sill. 200 foot to 120 foot by 6 foot oyster dome sills. We do call these sills, even though they're not that typical trapezoidal. And then one 80-foot vertical wall sill. We also replanted the marsh here, so did a marsh restoration project here. And the area of the vertical wall sill, again, is at the very end of where we protected the shoreline at that time. And we were getting a lot of energy coming around that vertical wall sill. So the marsh that we established had to be replanted a number of times, and still could use some more, or extending the project around the other side is would be helpful. You've seen this site before, but I just want to show it to you right after we completed this. This is the shoreline where we used loose oyster shell. And as we talked about, this does qualify in design for the general permit, but from a standpoint of marketing to residential, I think unless it is very low energy, this is going to be a tough one to sell, if you will, and or feel confident about its ability to stay in place versus some of the other approaches. But we wanted to see what happened here, and of course we were treated to a nice little hurricane that rolled right over here not long after it was put in place. So what you see here is that it's overbuilt in terms of its elevation. I think Lexia showed a little clip or a little photo of the contractor power washing it off of a small barge or little platform there, and creating a slightly higher 10-foot wide base, I believe, 8-foot high crest. And then nature does what nature does, which is work on it and then reestablish it into a lower, wider profile. Hurricane rolled through. I think I showed you all those photos last week. Hurricane came through, placed some of that shell up in the marsh, but it is still in place, welded against the marsh itself. And we still got oyster recruitment, but it does give you an indication where you have hurricanes or heavy coastal storms, or even large boatway erosion sources. This is going to be probably not your first choice or your second. So I wanted to share just a couple of site plan views, more so that you can go back to these when we get them when you get your final manual. This is a larger project. This is one that we did. Again, I showed you this on the Chewan River at the Eden House boat ramp with the Wildlife Resources Commission. What's unique about this project is that we took out a failing bulkhead here that had been in place for decades and decades, and Wildlife Resources Commission made a commitment to utilizing living shorelines wherever they could. When you look at the cost here, and I wanted to share those with you, you have to account for the fact that they provided their own manpower here. So when you look at cost, these are estimated based on what they think their in-house labor would be. They also brought their own equipment to the table, so they're great partners to have. But I wanted just to give you a sense, again, these are $2,004. The stone cost at that time was $27 per ton. We wish we could get our hands on that. Class 1, Class 2 riprap. And for those of you that might be designing larger projects, we wanted to share these plans with you so you can see design here. Included the cross-sectional view, so again, you get a sense of what the base width would be on this structure. This is very high energy. You'll notice in that last photo, I don't think I pointed that out. Let me back up for a second. You'll notice we did need to put in the brakes to comply with the permit conditions. And where we did that, we included a small amount of stone where the 5-foot brakes were, because before we did that, we were getting a lot of energy funneling through that little 5-foot gap. And so we added a little bit of stone, which is allowed under the permit, to dissipate that energy, but you still have that gap for fish passage and other critters. Again, the cross-sectional view. I'll just show you a couple of the slides here. So this is what it looked like before. And what we love about this site is their commitment to restoring the resource, if you will, high energy on the fresh side of the spectrum, and a huge parking lot back here that was draining into the waterway. Wildlife Resource has done a beautiful restoration project and stormwater project back here as well. So they infiltrate all their runoff in addition to restoring the shoreline. So this is the progression here from when we pulled out the bulkhead in 2004 to what that regrading looked like. What you can't see out here is we do have a turbidity curtain out here. This project, it's really important to maintain these turbidity curtains if you're going to do this level of restoration where you have to get in there with your equipment, and it's not pretty while you're in the midst of it, but it's worth it. Again, November at the end, this is what it looks like freshly regraded and before planting. By the next August, we've got freshwater species in here, and I include in the notes section of your manual what species we utilized here. This is a freshwater restoration project, and Ellen Kolodny was very, very helpful to us at this. And what we found, the winners here were not species that we would typically use in our region, but Zizaniopsis or water millet was the star here. And then some pickerel weed, sawgrass is very common up there. And we also used the opportunity here to restore the upland scrub zone and the tree zone. And I include those species for your use here if you're working in freshwater environments and where you have the luxury to restore not just the shallow subtidal, low marsh, high marsh, but where you're restoring right up through uplands. We also had, because we created a quiet zone back here that hadn't existed before, we ended up with submerged aquatic vegetation that volunteered in when Ellen monitored this after a year, and that was very exciting. So this is what it looks like in November of last year. I went and took a look. And what you see here is a very mature, very stable shoreline that includes that marsh zone, riparian buffer zone, tree zone. Many of these trees here have volunteered in even beyond what we planted. So we're very pleased with this site, and I think Wildlife Resources has done a great job of incorporating these techniques into many or most of their sites where they can. I want to include a couple of the innovative approaches for your consideration and encourage you all to join in on this. We've got some great partners that I'll mention in the next 2 slides, but it is where we're always open, and I think North Carolina is ripe for some more innovative approaches. Many of these companies do the work themselves, but they're also interested in selling their products to other contractors to use. And Sandbar is a good example of that. They've come up with some really, really innovative materials that are utilized in a number of our projects here. And basically what they take is kind of jute, fibrous materials that they incorporate that kind of dip in I guess, a concrete mix. It is patented, so I can't tell you everything that they do. But they're very, very welcoming for you to come and visit their facility and talk to them about pricing for these materials. And what's been great about this particular design and a number of these that Sandbar applies is that they set them up in the water column. And so we get oyster growth all through the structure, not just on the channelward side and on the tops, as you see with some of the sills, but you've got oysters growing all through here because there's so much open space and surface areas on their approaches. And I think that these are a winning design in many locations. I did not include cost estimates because that wouldn't be appropriate. These are, this is a private company, but they do welcome you to check them out on their website and or contact them if you want to talk about a project that you'd like to collaborate on or you want them to look at. And as I said, they let me know that they're very interested in working with other contractors to supply the materials, and you all can do the labor. And this is just the site that I think Lexia talked about. So in this particular design, you're seeing a couple of different things. There are basically log structures here. You've got crossbars. They are anchored into the ground with fairly deep members. And then in many cases, you've got something that looks like a table design. I'll show you a design of that in just a minute here. And what's fascinating about this, and to me fairly amazing, is you're seeing growth here between April of 2019 and October of 2020. And that's pretty phenomenal growth. I would encourage you to go visit this site at the aquarium. You can get there without trespassing, and you'll see our stone sills in very close proximity to this design. This is a project that we're currently working with them on in Topsail Beach, and I just show you this because they pulled out all the bells and whistles here. This is one type of innovative approach called a table. They then have these trapezoidal shape structures. Again, all of these have some sort of fibrous mat with this concrete mixture over them, and they're anchored into the sediment here. So they've got what's called catcher logs, pillows, and tabletops here in various designs. And the overall effect is that you get this sill type structure that should be very conducive for oyster settlement in the location that we're working together, which has a lot of boatway corrosion on Banks Channel behind Topsail Beach. I'm almost finished here. This just shows you the site plan view, and you can see these are really also can be designed into many different orientations. What's key is that you have both edges of that within the oyster growing range so that you don't have these structures above where oysters would naturally recruit onto them. And I want to include one more innovative approach. Again, I hope to have both of these products at Morris Landing. These are called Oyster Castles, also a private company, also supplies them. They do the work themselves, but they also will sell them. There's been a couple of nice research projects around the oyster recruitment on these. And again, you can build them like Lego style into different orientations. And where they are successful, you can kind of see they provide excellent surface area for recruitment, and they more or less create that trapezoidal shape structure that we're looking for with sills. And I invite you to go to their website. I also didn't include purchase or cost because that's not appropriate, but they can give you their innovative cost or their cost for their innovative approach depending on the design. One more tool that we include in the manual for you is there's lots and lots of case studies, which I find to be very, very helpful when I'm thinking about different projects. You can go to the Living Shorelines Academy website, which we helped put together years ago, And there are, as one of the tools in there, databases from a number of different states, including North Carolina, and you can click on any of these little pins here and see project information for all the projects that we've done and others have done in North Carolina. So we invite you to roam around through that. There's also 2 training sessions in the Living Shoreline Academy that might be just super fun for you to do in your off time. I'm being funny. I know you don't have off time. All right, well, that is the end of my presentation. So at this point, I'll turn it back over to Whitney. Take
Questions for Tracy?
Or any of our folks. We've got a lot of experts on the line here. We'd be curious to know if anyone wants to share any other case studies that might be useful to include in our manual or cost estimates. Again, we're trying to provide a relative range for folks who are thinking about getting into this business. But we're very much open to your input on this, either today or after the trainings.
Tracy, this is Chris Conaway.
Hi, Chris.
How are you?
Great.
I just wanted to mention that the Morris Landing project, we were very much glad to have the working space and the proximity of what it was. There was, you know, the big concrete pier that we were able to use to unload directly off onto those floats from, and it minimized a lot of our time and therefore enhanced, you know, some of the bang for the buck, so to speak.
Mm-hmm. Yeah, that's a really good point. You had the perfect equipment to float those over from the pier, and that is not always true everywhere. You know, when you're talking about oyster domes, particularly, you've got to get them to wherever you're putting them. In this case, as I recall, Chris looked like that scene out of the African Queen where he's pulling her in the barge. He's pulling these structures around the bend, but it was a really successful approach.
All right, not hearing any other questions or seeing them in the chat box, we will move on to our final presentation of the training from Ted Wilgus with the Coastal Federation, talking about maintenance, monitoring, and business opportunities. Over to you, Ted.
Great. Thank you, Whitney. So this is the most exciting section of the 3 training sessions right before lunch. So after 2 hours of training, so I'm sure you will be riveted to your computer screens, but thank you all for sticking through this. One thing that we have learned, this is definitely a developing process, sort of a developing product. So, you know, we're looking forward to your input. What we found is that, you know, contractors like Chris and fishers like Joe Huey and consultants will take something that we've produced and look for ways to adapt it, refine it, and streamline it in ways that we didn't even think of. And so we look forward to you all doing that and hopefully sharing some of what you've learned as you do that. So what we're hoping, our goals here are basically to let you feel comfortable on determining what you need to do to monitor and maintain a living shoreline project that you design, install, construct. So after construction, you know, what's required, what needs to be done, and how to interact with the property owner. You know, you all know that some property owners will call you every day asking, you know, what's going on here, what's going on with this. And so there's an opportunity here to be proactive in terms of trying to guide their interaction with you, but also an opportunity to potentially develop you know, maintenance plans that are a source of continuing income after the project. And also looking to how you can evaluate whether or not the project has been successful in terms of meeting the objectives of the homeowner, as well as the stated objectives of the project. Looking at what the permit requirements are. So some of these projects come with permit requirements such as installing visual markers or actually doing some physical or biological monitoring as part of the permit conditions for that project. So we want you to feel comfortable understanding, you know, what those are and then how to eventually implement them on your own, or how to farm that out to somebody else to do, potentially a researcher? And is there an opportunity to establish some kind of continuing fee structure for that? And then are there opportunities to have these projects generate, income for you, whether it's through a maintenance plan or other things that can keep you kind of in touch with the project? If there are any other objectives that you all kind of want to you hope to gain from this module of maintenance and monitoring, feel free to unmute yourself and chime in or put something in the chat box. But again, this is an area that, the Coastal Federation, we do on our own projects. And so we're continually learning to how to evaluate these monitoring and maintenance measurements, as well as the permitting agencies, because they want to know, are these projects, how they're performing, and what they can learn as they go through their kind of decision-making process. So, as we mentioned before, it's very much of a quality product. Just like if you're building another waterfront structure or a pier or anything like that, the more time and effort you put into the design, the consultation with the homeowner, and then the actual construction will be very beneficial to you for the long term. We found these projects are very resilient. We'll talk about it on the monitoring during storms. So again, the better you build them, the less work they require. But it's kind of up to you in terms of how you want to work with the homeowners. And it's not a great analogy, but it's kind of like your pest control management plan, where you either have the quarterly or the semi-annual plan where they come and spray, if you do that. But the idea is that you work with the property owner to figure out, how often they want you to be checking on this project. Is it something they can do, or is it something they want you to do? And you can structure your kind of cost to that. You could potentially have a lower initial cost. You say, well, normally this costs $10,000 per 50 feet. I'm going to charge you $8,000, but then we're going to put $2,000 in for a continuing maintenance plan over the next 5 years or something. So it's up to you. You can design what's going to work for your system, but having some kind of interaction with the project and the homeowner, property owner, after the project is built is something you should plan on, so that you can kind of stay in touch in terms of the control and the look of the structure, as well as making sure you have a very satisfied customer. And your maintenance and monitoring plan should be built on, what is the goal of the structure? Is the goal, a nice oyster reef in front of the property? Is it, shoreline erosion control? Is it, part of a pier structure? You really need to make sure that as you design these, as we talked about earlier in the earlier modules, that you're designing these with the homeowners' long-term goals in mind, and then you build the maintenance plans around those goals so they meet the goals. They might want a spot where they want to launch their kayaks and things like that. So you've got to keep that in mind. And then looking at what kind of maintenance there should be, again, with the depending on what the permit requirements are, you might have to have some actual monitoring as part of that. And whether you do that yourself or whether you link it as part of another business, whether you work with researchers or a consulting firm, and you charge the homeowner a fee, and then you subcontract that to a consulting firm to do the monitoring. And again, those are potential partnerships and business opportunities for you to consider. Again, it's that investment between you and the property owner as you do this. And you want to be very realistic with the property owners as you go ahead with the project. Explain that it's a living shoreline. Living means that it changes over time. You'll see oyster growth. You might see some materials move. Your shoreline vegetation might change over time. So it's not something that's static. These are also dealing with sea level rise. And so and storms, other forces. So this is not like building, it's different than building a pier. appears going to not really change a whole lot unless it gets damaged by a storm. A living shoreline is going to look different from year to year. And so you want to make sure they understand that. So having in your portfolio, pictures of what a living shoreline looks post-construction, immediately, 1 year after, so you can show them kind of how it develops over time is going to be really important. So homeowner might expect that it looks like an oyster reef within 2 months, and they're asking you, where are the oysters? If that's part of your design. So again, you want to kind of figure out what they want, be realistic with them so they understand how it's going to change over time, and then also what the maintenance and monitoring needs may be. And again, you can look at establishing your own inspection schedule where you're coming back once a year or twice a year or only after certain events or as needed. But again, that's something you can build into your overall contract or plan with the homeowner. You can also look at, do they want an osprey tower as part of their living shoreline? Are they looking for some kind of other things that you can build in as kind of like I guess when you design a home, whether you want the granite countertops or the other kind of granite, other countertops, you can kind of have add-on things that make a little bit more special if you want to. We don't do that, but something you guys could think of. And so moving on, in terms of maintenance, just general maintenance, things you might be looking at are, are the materials within your living shoreline, the rock, the bags, the jute logs here that you see, the core logs, are they moving at all? That's something that you might encounter. Again, the better you build it, the less movement you'll see over time. You need to make sure that the project stays in its permitted footprint. So if your project moves 2 feet landward because of storms or other things, you need to check with the permitting agencies and say, you've moved it, it's moved. You either need to modify your permit or move it back into its original footprint. Again, that doesn't happen very often, but that is something that you have to consider. Invasive species, as these shorelines develop, the elevation within them sometimes changes, and so it gets drier conditions, maybe less water flow. You might have things like Phragmites come into your living shoreline area, or you might have English ivy. There might be all sorts of things that might come into there, or even cattails, and they might dominate your system. And so you have to determine whether or not that's something the property owner wants. They don't care. They just want something out there, or no, they want their diverse, salt marsh or diverse freshwater marsh in front of their home. So you have to design a plan to figure out how you're going to remove that Phragmites or control it, or that ivy or those cattails, if that's something that the homeowner doesn't want. And again, that's something you want to try to build in or maintenance package that you add in after the fact and say, well, I see things are changing like we talked about. For the next 2 years, I can come in twice a year and pull out the Phragmites, and I'll charge you X amount for this. So those are, again, things that you can look at. As Lexia mentioned, sometimes you need to replant. And again, it's good to inspect these sites in the fall, early fall. That's kind of when the marsh is at its height. You can sort of look at the vegetation and see how well it's doing. Again, you can also do that through your monitoring. And then you can look at, well, next spring we need some more plants. And so that for additional fee, you will add 3,000 plants of these species. So those are things you might want to look at. And also just, things might happen that you didn't think would happen. You may build a sill and don't think oysters are going to recruit, and all of a sudden there's oysters all over your sill. Those are things you might need to do adaptive management, sort of tweak your project. Or if the neighbor really likes what you did on the neighbor's property, they want something there, maybe you can use the lessons learned from your original project and adapt those to the neighborhood property. You also want to provide kind of an instruction book, and there's things that exist out there already that you can either adapt or give them online. We'll put some of those resources in the chat box as well as the manual. But what to look for after a storm. You know, a lot of times after storms, you get a lot of debris deposited behind the sill structure, whether it's oyster or whether it's wooden sill or a rock sill. It acts as a catch sometimes. You get lots of debris. You want to remove that debris because once it sits on the marsh, it can kill the marsh vegetation. So those are something you can offer. It's like a post-storm inspection, assessment, and then clean out essentially. And you want to try to be proactive and identify any concerns early. They're always easier to fix, cheaper to fix if you can identify them early. It's a good idea to take photos, just like you have a portfolio of your projects. To take photos of the project, and so that you can document what's kind of the changes, and the homeowner can do that, you can do that. But the idea is that you're trying to identify all these issues and record them so that you learn, the homeowner feels like they're part of this process as well. And feel free to interrupt me if I'm going too fast, if you have any questions. So that was kind of general maintenance. In terms of structural maintenance, again, this is kind of what we talked about, but did you have a lot of bags moved? Did you have stones get shifted from a storm, or for whatever reason, do you need to put those back into the sill structure? Do you need to replace a board as part of a vertical wall sill, or the slats in the vertical wall sill have gotten clogged up with material? Those are all things that you can plan for and as part of your maintenance plan. If you have a sill structure that has gaps in it to allow for water and fish passage as required by a permit, you want to make sure those are in place, that you can get filled in over time. And you want to check to make sure the structure is still strong and intact. Any markers that got knocked down, you want to replace, remove that debris. So again, these are all sort of general maintenance. Some of your homeowners may be able to do all this themselves, and they say, I've got this, or they may be, this isn't their primary residence, they need somebody to check on it, or they're just not able to do it and they want you to do it. So again, these are all things that you can kind of have a menu of different maintenance options that you can supply your homeowners with to choose from. And you can feel very confident in your structure and the efficacy of these living shorelines. And you're saying, and if a homeowner says, well, I didn't ever have to do this before my bulkhead, you can say, well, the bulkheads generally last a while, then they fail. What we're designing here is a living shoreline that's going to be more beneficial, more effective. And because it's a living shoreline, it's going to adapt to the change. And we help your shoreline adapt with that change and make it more resilient and last over time. So you're not selling a defective product that needs maintenance. You're selling a very effective project that gets even better with continual care over time. Let's see. In terms of the vegetation, again, this is something that Lexia mentioned. You want to look and see, are you getting the same amount of coverage that you want with your living shoreline? Are your species surviving in the range that you planted them in? Do you need to add more plants? Do you need to change the planting regime? Those are all things that you can determine what's the best action. Removing any kind of debris that's behind the sill, that's on top of the plants that can kill them. And again, same thing, post-storm, these are all things that you can come up with. And again, seasonal, the living shoreline is going to look different in the spring than it's going to look in the fall. So you want to kind of, again, fall is best time to look for plants, see how your vegetation is doing early fall, and then anything you need to do is best done in the late spring before hurricane season starts. We generally like to get our plants in and do any kind of vegetation work as close as possible in the May, June period, so that if we do have storms roll through in July, August, and September, the plants have had a chance to root. So monitoring, this is, monitoring is kind of two different things. It can be just kind of checking to see how it's doing, and then there's actual sort of biological and physical monitoring of the project that's required, either as part of funding. If your project is funded through a cost share or a grant in cooperation with a nonprofit, or a municipality, you may need to incorporate some more detailed monitoring into your plan for care for the project. So that's something you need to count on. I don't, if you want to do the monitoring yourself, you certainly can. There is a fair amount of, there's a little bit of a learning curve, but there are opportunities to partner with, again, consultants, researchers, where you build that into part of a, as part of a fee, and you subcontract out to them to do that monitoring. But the monitoring helps to sort of demonstrate to the homeowner, hey, this project is successful, your marsh is stable, the structure's stable, you're building up sediment behind it, so it's doing what it wants to do. And so you can do that. There are other things you can do, but they require more training, more equipment, and a lot of times they aren't required. So, but it's something that there may be partnerships with other organizations, researchers, consultants that you can look at to investigate these further. Okay, now I'm going to change hats a little bit and present a couple slides from Dr. Carolyn Curran from NOAA. She's up in the Pivers Island lab for NOAA, and she has done a lot of monitoring of fringing marshes as well as living shoreline marshes. And some of this is fairly technical, but we wanted to kind of show you this so you can understand some of the monitoring that's being done. She's done work over 15 years to look at kind of how the marshes and the marsh edge change over time, both with natural marshes as well as behind these sills were incorporated with these living shoreline structures. These are an aerial view of a natural marsh. Never mind. So this natural marsh here, then you can see the one with the marsh sill. So you get an idea of kind of what they look like from an aerial view. And they also have transects through these marshes to look at different changes over time. And you can see they basically draw a cross section through the project area, and they're using this cross section to look at how the vegetation changes in each of those sections, going from sort of the shallowest area closer to the sill structure all the way up into the high marsh. And basically what this is looking at is how dense is the vegetation, how thick is it, as well as how much of the ground is covered by vegetation. That can tell us how healthy that marsh is. You can also look at how the elevation. And so generally when you build these projects, you tend to see sediment accrete or build up behind the structure. And so you want to measure that elevation change because that's going to tell you how they're performing as well as kind of how they're going to affect the vegetation change. And this is the one slide that scares us all, but basically what this shows is that so the blue line is a living shoreline marsh with a sill structure. The orange line is on both these graphs, is a natural fringing marsh. And what it shows is that over time in the upper marsh, that high marsh where you get the high tide bush, the salt meadow hay, your feet stay dry when you're walking around in the marsh. We see that basically gain and become more resilient and strong over time to a much greater degree with a sill project. Basically, that upper marsh becomes more resilient, stronger, and it actually essentially gains more sediment, so it maintains more stability. And then in the lower marsh and the fringe with the natural fringing marsh, again, you start to see you lose substrate. More quickly, you see sort of it gets deeper, so you see less of the salt marsh. It gets too deep for those salt marsh plants over time. When you have a living shoreline in front of it, you don't see that. What you see is usually more sediment gain. You do see a change in species from plants that like to be more wet to plants that be more dry as you gain more sediment. So that's basically what that slide is telling you. And again, this is not something you have to do or worry about. It's mainly just so you kind of understand that these are living shoreline. These are not static projects you're building. They change over time. You know, the sill is not going to march 10 feet forward or 10 feet back, but the sill is going to look different as it gains vegetation, whether it's algae or whether it's oysters in terms of life. And the marsh behind it's going to change depending on how it interacts with that sill. So again, you just want to be prepared to try to answer these questions and also talk to your homeowners as you design these projects. And again, very, very busy slide, but basically what this is kind of showing over time is that if you're looking at the left hand of your screen, you're kind of seeing these different, in each of these plots, what you're seeing is that the amount of plants, the density increased greatly in the sill projects, the living shoreline projects, to a much higher degree than they did in the projects without the sill. That fringing marsh tends to get lost more quickly without something in front of it to protect it due to sea level change, rise, erosion forces, and things like that. So, and then the upper marsh changes as well. So again, you're going to see changes over time. Some people are concerned about that and that you're changing one habitat from another. But in terms of, you know, what we think is the overall benefit, it meets an overall benefit, as well as with your property owner. They can see these changes, but it's still meeting their needs, depending on what their design was. You know, if they don't want to see any marsh vegetation change, then you may look at a very low profile sill. You just want something that's going to slow things down a little bit, but not change things. So again, that's what you have to come up with your property owner. And so what these pictures show, the one from Pine Knoll Shores, basically where they're standing with that pole and that PVC quadrat was where the fringing marsh had been. So all that was lost. So that was without a living shoreline. The middle picture is also from Pine Knoll Shores and basically shows you that with the sediment accreting behind this rock sill, you actually had the marsh extend all the way out to the sill. It used to be open water behind it because that structure is holding that sediment, is trapping that sediment. And then the sill picture on Harker's Island shows kind of how, again, you got more sediment, and this, what used to be a Spartina alterniflora marsh or kind of a wet marsh, turned into a drier marsh with this marsh hay. And so basically, over many years, what researchers have found is that you know, if you build a healthy marsh, it's going to protect a healthy marsh. It's going to provide a lot of the benefits, you know, of fish, shrimp, invertebrates, other animals utilizing that marsh for nursery, feeding, foraging, spawning. It's going to provide all those ecosystem benefits. So I think spending time monitoring those things is interesting, but not necessarily something you want to get involved with or have your homeowner get involved with unless they really want to. What's more important is looking at kind of the vegetation and how that changes over time, and then the elevation. Those are things that can be relatively easily done. You know, elevation can be done with a GPS. I don't even know the terminology, sorry, the backpack GPS, a Trimble, anything like that. You can get elevation changes. You can also use, you know, the traditional survey levels and meter sticks. There's all different ways you can do it, but providing that information to your homeowners is valuable, but it also can be farmed out if you need to, if you don't feel like that's something you want to do, feel comfortable to do, or if it's not required. Again, the general permit does not have these requirements as part of it. So you may not need to do any of this. However, you may have a homeowner who wants to know, you know, what's going on, and you want to be familiar with the options to be able to say, well, these are some things that we can do to monitor it. I can't do it, but I can point you to a consultant or a researcher who can do it for a fee. Those are things just to be familiar with. And so I'm going to wrap up here and just, I think the biggest thing we can stress is, you know, these are things that are an investment by the property owner, but they're also an investment by you and your company. You're learning how to do these. You're becoming proficient, adapting, you know, you're becoming a salesperson for these. So the better you build them, the better you take care of them, especially early on. It's going to yield revenue for you as well as be a very good marketing project. Yeah, if you build something quick and fast and not really working well with your homeowner and move on to the next one and it falls apart, that's not going to go well for you, just like any other thing that you build, design, or maintain. And you have a good project, it's very good advertising. And you all are probably better at advertising than we are, but there's things like, a yard sign, just like when you get your a new roof put on, they put a yard sign. You could do a pier sign. Again, there's all sorts of things that you can do that will help advertise your company. When people come to us looking for living shoreline information, we have a very short list of contractors that we can point to. And so the more contractors that are out there that can do this and do it well, the word will spread and we'll get more living shorelines, and hopefully you all will gain more business, and a business that also offers reoccurring revenue that you can be very proud of in terms of helping to maintain these essential shorelines. So I'll wrap it up with that. Again, this is very much a developing kind of process and product. I'll put in the chat box some of the resources out there for more information about monitoring these shorelines and maintaining them. As an organization, we have to monitor them because of our grants and also our permit requirements often. And we do it once a year, and that meets our requirements. Maintenance on all of these is usually fairly low key, but it's something we build in and we recognize. Sometimes in our grants, we can actually build that into our grant application, and funding is getting funding to cover those maintenance and monitoring costs. So again, if that's something that you have to do, if you can look at building that in on the front end of the cost or as part of a plan after the project is built, it's something that might be worth considering. So I'm going to pause there and see if anybody has any questions. Either unmute yourself, or if any of the experts want to weigh in, or you can put it in the chat box. But thank you all very much.
Thank you, Ted. Allison did have a question that was resolved in the chat box, but I'll just review it for everyone. She said that I understand a permit is not needed for planting, but for shell marl bags, is a new permit ever needed during maintenance? Is there a certain amount of repair allowed without a permit? And Tracy let her know that if you're just talking about normal maintenance, that would include replanting, moving debris, taking out any dead vegetation off structures, repositioning oyster bags that may have moved. There aren't any permits needed. If you need to modify the footprint design after the fact, you need to contact the Division of Coastal Management. And then Kelly Spivey, who's also with the Division of Coastal Management, said that a new permit is not required in order to repair and maintain less than 50% of the sill. It is a good idea to consult your DCM field rep in that area just to confirm that your maintenance is less than 50%.